Welcome to This Explainer. Today, we're diving straight into a truly fascinating intersection where cognitive science meets medical decision-making. We are going to be deconstructing a deeply insightful framework from the course Clinical Cognition from First Principles. Now, if you've ever stopped to wonder what is actually going on inside a doctor's mind when they're staring down a really complex case, or how medical software manages to model human reasoning, well, you are definitely in the right place. We're going to unpack the literal architecture of medical thought itself. So let's kick things off by looking at the absolute bedrock of modern medicine, evidence-based medicine, or EBM for short. Whenever a medical professional is reviewing a clinical trial or digging through population data, they're trained to ask one primary overarching question: can I trust this evidence? EBM gives us the crucial tools to evaluate the validity of all that external data. It's absolutely essential. But the framework we are looking at today completely flips that script. It asks a totally different, but honestly equally vital question. How did a clinician get from raw findings to a judgment in the first place? So while EBM is hyper-focused on the quality of external inputs, clinical cognition is strictly focused on internal processing. It maps the actual step-by-step movement of human thought. And this perfectly captures the core dynamic we'll be exploring today. It's like a two-part system. Evidence-based medicine provides the external data and the framework for trust. Clinical cognition, on the other hand, is the internal mental engine that actually processes and utilizes that data. You really can't have one without the other, right? I mean, you need a powerful engine to process high-quality fuel. Here is our quick roadmap for the 13 lessons we're covering today. First, the two halves of medical truth. Then, we'll deconstruct the core cognitive engine, look at auditing bias and failure, explore scaling to systems thinking, and finally, map out the path to clinical mastery. All right, let's jump right into Section 1, Two Halves of Medical Truth, Making the Invisible Visible. So usually in standard practice, we just see the final destination, right? The diagnosis scrawled on a chart. But this course explicitly traces the path taken to get there. It's illuminating that invisible reasoning. And what's super cool is that it's designed as a dual-track framework. That means it speaks the language of both the clinicians making the life or death decisions and the techies, the software engineers trying to build AI to support those decisions. And this is where things get really interesting. Lesson 2 introduces something called the Socratic loop. Basically, it uses an AI constraint to force a learner to actually attempt the reasoning themselves, asking questions instead of just handing over the answer. The source material points out that this constraint radically boosts retention, simply because the learner has to do the cognitive heavy lifting themselves. Moving on to Section 2, the core cognitive engine. Let's deconstruct this mental machine. Let's see how this engine is actually built in Lesson 3. A doctor doesn't just magically leap to a conclusion. They take raw findings and methodically build what's called a stress-tested, probability-weighted differential. Basically, that's a ranked list of possible diagnoses. But here is the kicker. It doesn't stop there. The engine always finishes with a self-critique pass. It audits its own reasoning before finalizing a judgment. Think of it like a mechanic rigorously revving and testing a car engine on a block before they ever dream of dropping it into a chassis. Which brings us to Section 3, auditing bias and failure, or finding the exact breaking points. Because, let's be real, any engine can fail when you push it hard enough. Lesson 4 is basically a massive stress test for cognitive bias. It looks at the precise moment of commitment to a diagnosis. It identifies the single load-bearing finding that's holding a whole theory together. It separates signal from noise, looks at how logic gets distorted during a handoff, and demands a full retrospective audit. It is an incredibly exhaustive diagnostic of the diagnostician. Now, since no one practices medicine in a total vacuum, Lesson 5 brings in the patient advocacy track. This emphasizes structured longitudinal state logging, which, I know, sounds like a lot of jargon, but in plain English, it just means translating your complex reasoning so it actually survives handoffs. It ensures the why makes sense to the nurses, the specialists, and the next shift doctors who are taking over, not just the person who originally had the thought. All right, Part 4, Scaling to Systems Thinking. We're zooming out from single minds to entire organizations. Lessons 6 and 11 really highlight the shift here. When you move to registry-level workflows, the whole game changes. The scope shifts from just one patient to a whole population. Workflows change from a solo diagnosis to distributed handoffs across multiple agents. And the analysis? It goes from a personal audit to systems-level root cause analysis. This is where individual cognition and massive population analytics genuinely diverges. To handle all that massive complexity, Lesson 7 borrows a brilliant concept straight from engineering and aviation called FMEA, Failure Mode and Effects Analysis. Instead of just hoping an individual makes a safe decision, this applies mechanical safety protocols to entire clinical workflows. It's a way to systematically hunt down and fix potential failures long before they ever reach a patient. Then, in Lesson 8, we add a crucial layer of calibration around how we actually use evidence. It introduces multi-domain confidence reporting. This is a very intentional move to avoid using one simple, oversimplified score to represent highly complex, independent judgments. By shadow reviewing these reports, the system ensures the weight we give our evidence isn't skewed by a single metric. By Lesson 9, the core loop is fully built. The master protocol is run end-to-end on one single case. This involves reading the entire reasoning trace back as one unified artifact, just to verify if the logic truly holds together from the first observation to the final judgment. It's literally the ultimate dress rehearsal for the cognitive engine. Finally, we hit Section 5, the path to clinical mastery. This takes us way beyond just making a single diagnosis. Lessons 10 and 12 explain how personalized care is actually a layer sitting right on top of this engine. And it requires serious metacognition. Clinicians have to ask, do standard rules even apply to this specific patient? This is exactly where our clinical cognition engine wrestles directly with evidence-based medicine. Doctors have to actively resolve conflicting evidence, weigh what the patient actually wants, and purposefully document any deviations from protocol to achieve real precision medicine. Lesson 13 takes on the absolute pinnacle of the profession, clinical wisdom. How do you capture that gut feeling, tacit knowledge? Better yet, how do you tell the difference between a master's genuine expertise and a beginner's dangerous shortcut? The secret lies in constantly, deliberately auditing your own compressed intuition over time. Oh, and if you're hungry for more, the source material includes an appendix with 5 optional electives. They let you take this whole structured framework and apply it to things like N-of-1 research, evaluating medical journals, or even cross-case learning out in community medicine. Which perfectly circles back to the main thesis we've been focused on today. Evidence-based medicine and clinical cognition, they are quite literally two halves of the same whole. EBM brings the rigorous data, cognition brings the rigorous reasoning. As the course itself says, the two are complementary, not sequential. You can start with either, but together they build complete medical competency. So, as we wrap up this explainer, I want to leave you with a question to chew on. When you're facing your next incredibly complex problem, whether you're in medicine, tech, or really any field at all, which half of the truth are you going to master first? The external evidence you rely on, or the internal engine of your own reasoning?